Cobalt is a ferromagnetic metal that is typically found in association with nickel, copper, and iron ores. The geologic setting and environment of formation of cobalt are diverse. However, some of the common ones include magmatic copper-nickel deposits, which are formed through a complex process involving the cooling and solidification of magma. This process starts with a partial melting in the upper mantle, producing a magma-rich nickel, copper, and other metals. Then this magma rises through the crust, driven by its buoyancy and pressure. After that, the crystallization of minerals like olivine, pyroxene, and plagioclase follows as the magma cools and undergoes differentiation. Therefore, heavier minerals like nickel and copper sulfides settle down at the bottom of the magma chamber. Then the sulfide liquid accumulates at the base of the magma chamber, forming a layer of sulfide-rich material. And what follows is that the magma chamber cools and solidifies, trapping the sulfide liquid and forms a solid ore deposit. Sulfide minerals, including pentlandite, that is nickel iron sulfide, and chalcopyrite, which is copper iron sulfide, accumulate and concentrate, forming economic ore deposits. These ore deposits may undergo metamorphism, folding and faulting, which affect their geometry and mineralogy. And later on, these deposits may be exposed to weathering and erosion due to an uplift process, and this can lead to the formation of secondary nickel, copper, and cobalt deposits. So, the formation of magmatic nickel-copper deposits involves a complex interplay of magmatic, crystallization, and solidification processes. Another environment of formation of cobalt is sediment-hosted stratiform copper deposits, which are formed by a complex geological process. Here is a simplified model. A rift or an extensional basin forms, creating a depression where sediments like sandstones, shales, and carbonates are deposited. These sediments undergo diagenesis processes such as compaction, cementation, and mineralogical changes, forming sedimentary rocks. After that, hot metal-rich fluids circulate through the sedimentary rocks, often driven by magmatic or tectonic activity. When these metal-rich fluids interact with the sedimentary rocks, minerals like chalcopyrite, bornite, malachite, and cobaltite are concentrated to form economic ore deposits. And again, such ore deposits usually pass through several episodes of metamorphism and deformation that affect their geometry and mineralogy, and if they are somehow uplifted, these deposits are going to be exposed to weathering and erosion, forming secondary ore deposits. Stratiform sediment-hosted copper deposits often form in reducing environments where the presence of organic matter and other reducing agents helps to concentrate copper and cobalt. Cobalt can also form in volcanic rocks through hydrothermal activity, where hot fluids circulate through the rocks and deposit minerals. In sedimentary environments, cobalt can also form through the weathering and erosion of its source rocks, typically mafic and ultramafic rocks. Common cobalt-bearing minerals. Cobaltite, a common cobalt-bearing mineral that forms in volcanic and sedimentary rocks. Eriserite, a secondary mineral that forms in oxidized environments. Glaucospherites, a cobalt mineral that forms in hydrothermal vents. Cobalt is often extracted as a byproduct of copper and nickel mining. Some of the most significant cobalt deposits are found in the Democratic Republic of Congo, the world's largest producer of cobalt, with many deposits found in the Cobalt Belt region. Canada, that is a significant producer of cobalt, with many deposits found in Ontario and Quebec. Australia, which is another important producer of cobalt, with many deposits found in Western Australia and New South Wales.